Welcome back. We're still in lesson 2. We're going to take a look at another example of how to use an algebraic technique to solve a linear equation. Quick recall, algebraic techniques, we isolate the variable using inverse operations. We remember the fact that in algebraic techniques, the inverse we apply depends on equation type. When we're solving an equation algebraically, the type of equation matters. We got to change our approach depending on which type of equation we're going to solve. Let's pretend that we're walking down the street of downtown Palo Alto and the local Palo Alto math thugs approach us and say, "Hey, solve this or else." And we're like, "What the hell, man? Back off." But then we're like, all right, I'm going to be nice to these guys because obviously they don't have anything else better to do with their life. We take a look at this problem and we say to ourselves, all right, here's some math stuff on the page. The first thing we're going to do is read the problem. Use any algebraic technique to solve the equation 5 minus x equals 2x minus 5 quantity divided by 3. Anytime we see math stuff, I always say, like, it kind of feels like I got hit in the face. One way I recover is ask myself in this class, is there an equal sign? Yep, there it is. We see an equal sign. Yay! Anytime we see an equal sign, we call the entire thing an equation. What do we do to equations? Dun, dun, dun. We solve them. Let's remember, when we write a solution, the solution is going to be in the form variable equals value. That is now our target. That's the thing we're working towards. We're going to get the variable, which in this case is x, by itself on one side. We're going to get the value of that variable, which we hope is a solution, on the other side. Next question we ask ourselves, after we have identified that there's an equal sign, it's an equation we're going to solve, get it in this form. What type of equation is this? No squared, can't be quadratic. I don't see any absolute vodka, even though I kind of feel like some. There's a ratio here, so maybe it's a rational, but notice there's no variable in the denominator. We said that rational equations had to have variables in the denominator. That's not it. There's no powers, and there's no radicals. Again, we're thinking linear. Another way we thought about linear is it's kind of like mx plus b. There's a negative 1 for the m, and the b is 5. Over here, it looks like 2/3 for the m. b is negative 5 over 3. It's another way to see that it's linear. Let's proceed with our solution. First thing we do is we rewrite the entire equation in our own handwriting. I always like to say that you are the best mathematician in your life. I mean that. Every other mathematician is a bum, but you're very special. Don't use other people's handwriting, use your own. Once we've written the original equation, we're going to ask ourselves, how do we isolate those variables? I don't really know what the first step I want to do, but I can tell you this. You see that little fraction right there? I don't like it. It's like all up in my grill, and I don't want it around. I don't want to see it. I don't want to deal with it. One of the first things I might do is say, fractions suck. How do I get rid of fractions? What is the way that I undo fractions? If we think about this entire thing as a fraction and I want to undo the division by 3, do you remember what operation inverts division? Dun, dun, dun. Yep, you got it. Multiplication. Multiplication undoes division. If I multiply on the right-hand side, I should also multiply on the left-hand side. This one's kind of crazy. Here I've got 3 over 1 times 2x minus 5 divided by 3. One of the things that we will see in division, and maybe some of you have seen these before, when we're doing this multiplication, we can actually bring the 1 and the 3 anywhere we'd like. The nerdy way to say that is, multiplication is commutative. I can switch the order. But it just means I can bring this 3 over there and that 1 over there. We know for sure that 3 divided by 3 is 1. And then one of the things that we're going to see is when we cut 2x minus 5 into one piece, we're not doing anything to that. That stays the same. One of the immediate things we might notice is that 1 times anything is the thing we started with. So 1 times 2x minus 5 would just be 2x minus 5. Over here, we've got a multiplication. Here we've got a subtraction. We can do this thing called, I'll make it right. I'm sorry. Distributivity of multiplication over subtraction. I forgot I was a mathematician. I thought I could be a normal human being and quote stuff that makes me smile. All right, 3 times 5. I have a minus, then I have a 3 times x. 3 times 5 is 15. Here I've got 3 times x. Here I've got 2x. There I've got minus 5. The next question we might ask ourselves is, we want to get x by itself. Should I bring the 2 over this way or the 3 over that way? I'm going to say, negatives bring down my life. They're not worth it. Bye, Felicia. Minus 3x plus 3x, those disappear, and I'm left with 15. I have 2x, I add another 3x. 2 plus 3 would be 5 of those suckers. And I got a 5 on this side. Now I want to get rid of that negative. To get rid of a negative, I use the inverse operation of subtraction, which is addition. If I add on the right-hand side, I've got to add on the left-hand side. 15 plus 5 is 20. Minus 5 plus 5 is 0. But remember, because 0 plus anything is the thing we started with, we don't actually write that down. Now, this is where things get crazy. I'm running out of room. I'm all up down here on my paper. You know what a novice mathematician does? A novice writes over on the edge of the corner, messes themselves up. You know what a pro does? Gets another piece of paper. And I always like to say, there's too many rookies, not enough pros. So don't be a rookie. Don't write on the little side of the paper if you're running out of room. Go get yourself another sheet of paper and continue your work there. Remember, that's a multiplication. I want to get x by itself. How do I undo multiplication? Well, I divide. If I divide on the right-hand side, I also divide on the left-hand side. Here we've got 5 divided by 5 is 1. 20 divided by 5 is 4. We also know that 1 times x is x. So now I have x equal to 4. I haven't checked my work yet. Thus, I cannot box it and check it. But what I will do is substitute x equal 4 back into that original equation. Everywhere I see an x, I drop in a 4. This is a question mark. I'm not sure if this is true. 4 minus 5 divided by 3. Let's take a look. 5 minus 4 is something like 1. 2 times 4 is 8 minus 5 divided by 3. 8 minus 5 is 3. 3 divided by 3 is 1. Indeed, 1 is equal to 1. I see that this is a solution to my equation. So I box it and move on. Quick review of what we just did. We started by reading the entire problem. When we saw the math statement that made me feel like I got hit in the face with a right hook, first question we asked ourselves is there an equal sign? In this case, there was. We called it an equation. When we're working with an equation, we solve them. A solution looks like variable equal value. We then began our problem. I'm going to give a shout out to myself. Yay! You see that? We make green when we rewrite the problem. We make that sweet green, right? We rewrite our problem. We have our equation here. We write an equivalent equation that comes from doing some algebraic work. We connect those with the implication sign. Notice we're going to space our workout. We're going to leave a bunch of space. Look at that little more green. Look at all that green I got. I'm making green. I'm making paper. So now I got my next equivalent equation. I go down to the next one. Look, again, I make some more green right here because I'm doing good habits that make my work a lot easier. And I'm 100% serious. I made a lot of money in my life with math. I mean, enough to pay bills, right? I'm not joking that you can make green with this. I'm not going to say all you have to do that, but these habits can help you really succeed in this class and make math a lot easier because then you don't get in your own way. Here we go down to the next one. When we ran out of paper, we didn't do a rookie move and look it over here because there's too many rookies, not enough pros. We got a new set of paper, work down to the end. Notice in every single situation, all my implication signs are lined up. We got to the final piece before we boxed and checked. We actually took the value that we thought was the answer, the solution, put it back into the original equation, checked that the left-hand side is equal to the right-hand side. That is true. We box and go. I'm into hip-hop, in case you couldn't tell. You ever seen a hip-hop artist drop a mic? When you see a mathematician box an answer like that, that's like dropping the mic. I know it's a lot more fun in hip-hop, but that's a little swagger for y'all. If you do this well, drop that mic at the end of the problem. Put that box in, give yourself a pat on the back, and go make some more paper. All right, I'll see you in the next video.